Let's begin with the problem. We discuss the factors affecting permeability of soil by considering various factors like a unit weight of percolating fluid and dynamic viscosity of fluid. We derive a relationship that is K1 upon K2 is equal to gamma W1 upon gamma W2 multiplied by mu2 upon mu1. And based on that, there is one problem. So I'm going to read the problem. So concentrate. Due to increase of temperature, unit weight and viscosity of percolating fluid reduces to 90% and 60% respectively. Then what will be the change in the permeability? So for that, I'm going to assume initial value K1 as K, final K2 is unknown, then we have to calculate what is the change in the permeability. Initial unit weight gamma W1 I will assume as gamma W. Unit weight after change of temperature reduces to 90%. See, try to understand the difference between two words, reduce to and reduce by. Reduce to म्हणजे तिथपर्यंत अवेलेबल आहे आणि रिड्यूस बाय म्हणजे तितक्या अमाउंट न व्हॅल्यू कमी झाली. आता हे रिड्यूस टू 90% म्हणजे 90% त्या व्हॅल्यू शिल्लक आहे म्हणजेच कितीने कमी झाली 10%. ओके, so reduce to 90% reduce to, so gamma W2 becomes 0.9 of gamma W. Initial च्या 0.9 शिल्लक आहे, reduce to 90%. Initial dynamic viscosity I'm going to assume as mu. So dynamic viscosity after increase of temperature mu2 becomes, it is reduced to 60, so 0.6 times of mu. Now let's arrange these assumptions in the expression. So K1 becomes K, K2 as it is, gamma W1 becomes gamma W, gamma W2 0.9 gamma W multiplied by mu2 0.6 times of mu divided by initial mu1 is mu, so mu get cancelled, gamma W get cancelled, so K upon K2 equals to 0.6 divided by 0.9, that is equal to 0. Or we can write like this, when we solve this directly we get the answer. K equals to, the value comes 0.6 divided by 0.9, 0.667 K2. But we want K2, that is the permeability after change of temperature. Therefore K2 equals to 1 upon this answer, so it becomes 1.5 times of K. What is the meaning of this? When temperature increases, permeability increases by 1.5 times of initial permeability. If you observe the second problem given in your notes, the second problem is having same calculation. Okay, but where is the difference? Read the problem carefully. Due to change of temperature, in your problem number 2, due to change of temperature, unit weight and dynamic viscosity of percolating fluid reduces by 10%. आता reduce to नहीं है, reduce by 10% and 40% respectively. Then calculate change in the permeability. The change काय करायला बघा. Initial I will assume K1 as K, final K2 we have to calculate. Initial gamma W1 I am going to assume gamma W, gamma W2 that is percolating fluid. आता हे काय येईल बघा. आता इथे काय दिलंय, reduced by 10%. 10% कमी झालं म्हणजे शिल्लक किती आहे 90%. So its meaning is 0.9 times of initial gamma W. Similarly, initial mu1 if I assume mu, then mu2 equals to what? It is reduced by 40%. Reduced by 40%. 40% कमी झाली विस्कॉसिटी म्हणजे किती शिल्लक आहे 60%, that is 0.6 times of initial. Now if you observe the values which we written for the final condition, these values are same as the previous problem. Therefore answer for K2 remains same, 1.5 times of K. Okay, so here completes the two logical problems based upon the relationship. So again important note given in your note, with increase in temperature permeability increases, okay, because of decrease in viscosity. Now let's move to the fourth property or fourth factor affecting permeability, and that is degree of saturation. Fourth property or fourth factor affecting permeability of soil is the degree of saturation. Whenever we consider a moist soil or a natural soil, it consists of three phases: air, water and solids. Air and water combined will be called as a voids through which a water is going to percolate or any fluid percolates. Means if void spaces are there, then only there is a possibility of flow at the faster rate. In case of moist soil, void spaces are trapped by the air, and that presence of air creates obstruction to the flow, and due to that obstruction permeability reduces. But in case of full saturation soil, all the voids are completely packed with the water. Air present is zero. Therefore, there is no resistance by the air. As there is no resistance, flow will occur at the faster rate. Therefore, very important line you mark by different color pen. It is given in your notes. A fully submerged or fully saturated soil will have higher permeability than partially saturated soil or moist soil. Now, fifth property, that is adsorbed water. What is adsorbed water? It is the deposition of water molecules on the surface of soil grain, and when this adsorption exists, the void spaces reduces, because if void spaces are more, then flow will be occur at the higher rate. If void spaces get reduced, then flow reduces. In the diagram, if you observe, this orange color indicates adsorbed water, and because of this adsorbed water, the void space reduces, and due to which there is a resistance or decrease in the flow through a soil mass, and that decrease is called as reduction in the permeability. So what we learn from this, very important line for 1 mark question: adsorbed water reduces permeability due to decrease of void spaces. So in your notes, that point is given. Due to presence of adsorbed water or diffuse double layer, void space get reduces, which resulted in the decrease of permeability. Okay, so after this, two more properties that affects permeability, that is specific surface area and the effect of stratification. Look at the board. The sixth factor affecting permeability is the specific surface area. About specific surface area, we learn in geotechnical engineering. Specific surface area is expressed in centimeter square per gram. It is expressed in cm square per gram. I told the meaning in geotechnical engineering subject. What is the total surface area present in a 1 gram of particles? Okay, and then we learn specific surface area decreases with increase in size of particle. In other words, specific surface area increases with the decrease in size of particle. Therefore, clay shows highest specific surface area and gravel shows least specific surface area. Permeability is inversely proportional to specific surface area. The meaning is, as specific surface area increases, permeability value decreases. Therefore, clayey soil which is having highest specific surface area shows lower values of permeability. Okay. and gravels which have higher values of lower values of SSA will show higher values of permeability. Okay, this is about SSA. Now let's move to the seventh factor affecting permeability, that is stratification or layered soil concept. Here on board, if you observe, the soil present in a single layer, means top to bottom is a single uniform soil or same type of soil. Then permeability is considered to be uniform or constant value. But if soil is having different profiles, is for this zone soil is different, for this layer soil is of different nature, again third soil is different nature. When soil profile changes, permeability value may not remain constant, it also changes. So that permeability we call as a variable permeability, means whenever soil is having uniform particle size and uniform nature, only single value of K is sufficient to express the permeability. But in case of layer soil, we have to calculate permeabilities for every layer, and then we have to express the average permeability of that particular soil mass by considering layer effect. Okay, so here completes the factors affecting permeability. Now let's move to the next concept. Next part is methods to find permeability of soil. This is the most important part where problems are involved and some logical terms are involved. Methods are divided into two groups, laboratory methods and the field methods. So here the first important part to understand is which method is applicable for which type of soil, that we call as suitability of method for a particular type of soil. So first, methods are grouped into two sections. Laboratory methods, the instrument used in the laboratory for measurement of permeability is permeameter, and field methods. So first we will discuss laboratory methods. In laboratory method, the first method is constant head method. Head during the test is kept constant. How this method works we will discuss in detail later on, but for time being we have to focus only on suitability. So constant head method is applicable for coarse grained soil where permeability is more than 10⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻ Remember, method and suitability is very important for 1 mark question. All suitabilities and methods are very important for 1 mark question. Sometimes is the question to match the pairs. One side column they provide the name of the method, and right side column they provide the type of soil. You have to match the pairs according to the suitability. And sometimes in problems they will not mention the name of the method. They will mention type of soil, and based on the type of soil we have to decide which method is used to solve that particular problem. Okay, so concentrate. Constant head method is suitable for coarse grained soil like gravel and sand. Variable head method, also known as falling head method, is suitable for fine grained soil like fine sand and silt, whose permeability is in the range of 10 raised to minus 2 to 10 raised to minus 4 cm per second. Consolidation test. This method is suitable for impermeable clay. ज्या क्ले मधून इझिली वॉटर फ्लो होऊ शकत नाही अशा क्लेची परमेबिलिटी काढण्यासाठी we use consolidation test where permeability is less than 10 raised to minus 6 cm per second. Very important, impermeable clay, consolidation test. And the fourth method is capillary permeability test. This method is suitable for partially saturated soil, especially clay and silt, where possibility of development of capillary fringes is there. More susceptible soil for the development of high rise of capillary is the clayey soil. Therefore, to determine permeability of such a partially saturated soil, we use capillary permeability test. Now let's move to the field methods. let's discuss field methods. Field methods are performed on field itself. That's why these methods are providing more accurate results. Field methods are of two types. Okay, pumping in test and pumping out test. In pumping in and pumping out mechanism is same. We are going to extract the water from the ground surface, and during the process of extraction we are going to measure actual permeability of soil. In a pumping in method, pumping in very important question for 1 mark, you make underline for that statement. Most accurate method among all is as far as laboratory methods are concerned, and pumping in and pumping out method is concerned. Overall, in all methods it provides more accurate results used for non-engineering projects, such like the projects like bridge construction, the projects like multi-story tower construction, projects like large flooring surface. For these we always conduct pumping in test. So all major engineering projects results are verified by pumping in method. It is applicable for any type of soil. There is no specifications and no restrictions. Just like in laboratory method we have restrictions, we have to use a particular method for a particular type of soil. But here we can use this method for any type of soil, because we are going to make a bore well inside the ground, and from that bore well we are going to extract the water. That is rate of extraction Q, height of groundwater available, and drawdown S means Q, drawdown S, and height of groundwater H. By using these three terms we are going to write expression for finding the permeability. This method we are going to discuss in detail later on. Now let's move to the next method. One more point about this pumping in method. It is the most expensive method because the setup required for digging bore well, the setup required for the extraction of water is very expensive and time consuming, but the results are more accurate. Now come to the pumping out method. In pumping out method, again we are going to extract the water, and this method you make underline by different color paint, most suitable for testing rocks and individual rock stratum. जिथं impermeable layer असेल म्हणजे rock surface असेल तर त्यासाठी pumping out method ही most effective असते. This method is conducted by two approaches. The first one is open end test and the second one is Packer's test. हे टेस्ट कशा काम करतात, याचं वर्किंग कसं असतं, that we'll discuss later on when we start discussion on methods in detail. So after this, here is the completion of field methods. Now we'll discuss in the next part laboratory methods in detail, beginning from constant head method. Let's start discussion on first method for determination of permeability, that is constant head method. From the name of method itself, one can easily understand the total head is going to remain constant throughout the test. Total head maintained constant throughout the test. You mark this sentence by different color pen. It's very important for 1 mark question. If total head is constant, then head loss remains what? Constant. What is head loss? Head loss is nothing but initial head minus final head. Initial head minus final head. But initial head and final head throughout the test remains constant. There is no drop of head. That's why head loss remains constant at every stage of test. Okay. Analysis of permeability is based on Darcy's law. To verify the calculations for getting the answer of permeability, we are going to use Darcy's law. But before starting the application of Darcy's law, let's discuss how this method is conducted in laboratory. Okay, so for that, look at the board. This is the instrument we call as permeameter. It's 1 mark question. Permeability of a soil sample is determined by using permeameter. Okay, so here this is a small standpipe whose diameter is according to the apparatus, means it is variable for variation in the apparatus and sometimes variation in the change of type of soil. How this diameter changes we will discuss in our next method, variable head. So this is a pipe which is full of water. The hatched portion indicates a soil mass. Fill up in a permeameter. The soil mass is filled by using the process of standard Proctor test. The soil mass is filled in 3 layers and each layer is compacted by using standard Proctor with a known mass of 2.6 kg. Now the height of soil sample is denoted by symbol L. At the base of this soil mass there is a instrumental plate which is going to collect the discharge when flow occurs through a soil mass. Means flow is going to occur in vertically downward direction. When flow slowly enters in a soil mass, it needs certain time to percolate through a body of soil mass and then slowly travels and comes at the bottom. And when it comes to the bottom portion, it is collected in a separate measuring jar by using time mechanism. Means to get the value of a discharge, we are going to measure the volume of water collected in a specific time. What is the formula for discharge? Discharge is nothing but volume upon time. So we are going to measure how much is the volume collected in a designed time. Volume of water is known, time is known, we can get the value of discharge. Okay, now let's move to the application of Darcy's law. According to Darcy's law, velocity of flow is directly proportional to hydraulic gradient. To remove this proportionality, V equal to K into I, where K is the constant known as coefficient of permeability. I am going to rearrange this. V is equal to V upon I is equal to K. Okay. So what is velocity and I here? Velocity is nothing but discharge upon area. The velocity is discharge upon area. Velocity meter per second is nothing but discharge upon area, and this is called as velocity. And I is hydraulic gradient. What is the formula for hydraulic gradient? Head loss per unit length of soil sample. So H by L. Now I am going to replace these terms in the expression. V replaced by Q by A is equal to K into I. We are interested to get the value of permeability. Now replace I equal to H by L. So Q by A is equal to K into H by L. Now I want value of K. So transfer. So Q into L divided by A into H is equal to K. This expression is used to find out the value of permeability. This expression is used to find out the value of permeability and expressed in either centimeter per hour or meter per second, depend upon the data available as a given data. Okay. Now in this expression, if I am going to express the meaning of each term, Q represents discharge through soil. Now tell me how to get this discharge. For that, the concept I explained, we are going to set a stopwatch, take a stopwatch and start the stopwatch by setting the standard time, and suppose time set is 2 minutes, and hold the measuring jar to collect the outlet water, and within that time span of 2 minutes, how much water is collected in a measuring jar, that volume we are going to use to calculate the discharge. Discharge we have to calculate by using the volume of water collected in a specific time t. So discharge is equal to volume upon time. Okay. Now suppose the volume of water collected in a measuring jar is measured in ml. Okay, it is in ml, and time recorded by using stopwatch is in second. then it is very important to convert that ml to meter. Okay, so remember 1 ml is equal to 1 centimeter cube. That is very important. 1 ml volume is equal to 1 centimeter cube. Okay, so directly you can get this value, centimeter cube per second. Okay, now let's move to the next term available in this expression, that is L. What is L? L is length of sample in a direction of flow. That is very important. Sample length is always measured in the direction of flow. So L stands for length of sample in direction of flow. Now next term A. What is A? Area of soil. But remember, soil is filled in a permeameter. So area of permeameter is nothing but area of soil. So area of permeameter, it is a device, permeameter. Okay, what is the area? Pi by 4 d square. Whatever is the diameter of that permeameter, is the diameter. Measure the diameter and pi by 4 d square, you will get the area of permeameter. That area is nothing but area of soil. The next term H. What is H here? Head loss or head causing flow. Head causing flow. And whatever units we are going to use for discharge Q, based on that unit we have to arrange other terms. Then other terms arrangement is in a same respective units. Then permeability is corresponds to unit assigned to discharge. If discharge is in meter cube per second, then K permeability is in meter per second. If discharge recorded and entered in the expression cm cube per second, then permeability is centimeter per second. Okay, so this is all about expressions for finding the permeability by using constant head method. In your notes, one point is given. You mark, underline by different color pen. Permeability is calculated by using values of discharge. Permeability is calculated in constant head method by using values of discharge. Okay. Now, to practice more in conversion. See, in this expression, this symbols and the meanings is very simple. Only fact is, the chances of silly mistakes is when you are going to replace the value in the expression, then unit conversion is very important. Okay. Now let's move to the second method of measurement of permeability, that is variable head method, which is also known as falling head method. Second method for finding permeability, that is variable head method, also known as falling head method. Again, from the name one can easily understand, head of water is not going to remain constant during the process of test. In our previous method, constant head, so head remains constant, your head is variable. So few important points about this method, and these points you have to mark by different color pen in your notes. The first point is, initial path is generated in a soil whose permeability is to be determined. What is the initial path? See, soil, when we fill soil in a permeameter, the soil is filled by using the process of standard Proctor test by compacting. And if the soil is clayey or a steep soil, and when we release the water for the percolation, then water needs more time to create the passage in a soil mass through which it passes. Unless and until water reaches the bottom of the permeameter, we cannot find the value of permeability. That's why before conducting the practical in the laboratory or before taking the readings of the readings for finding the permeability of soil, we have to create a seepage path in a soil mass whose permeability is to be determined. Means, first of all, I am going to fill the soil mass in a permeameter, and then I release the water, and time by time, with progress of time, the water is creating the passage in a soil mass. It may require 1 hour, it may require 1 day, it may require 1 week depends upon the steepness of soil, and once that seepage path is generated in a soil, then soil sample is ready to conduct the test for finding the permeability. Okay, the second important point is head is falling with respect to time, means as time changes, head of water from its initial level is going to drop to another level. Okay, next two notes are given in your note. These notes are very important. This test is not recommended for clays. Very important sentence for 1 mark. Variable head test is not applicable or not suitable for clayey soil. Okay, because clays are very fine in size and they are very steep, so they needs more time for creating the seepage path, so not practicable. And discharge is not measured. During this test we are not going to measure any sort of discharge to find out the permeability. In a previous method, constant head, discharge is essential. Without discharge we cannot find the value of permeability, but in this method there is no need of measurement of discharge. Okay, now let's concentrate on the equipment and its procedure. At the top there is a slender pipe whose diameter is very small, 1 centimeter, 2 centimeter, 2.5 centimeter, like this. Very small glass pipe is there. That glass pipe is connected at the top of the permeameter. Inside the permeameter, soil is filled. The area of soil mass inside the permeameter is equal to area of permeameter. Okay, that denoted by symbol A. The height of permeameter is nothing but length of soil sample in the direction of flow. Flow is coming in a downward direction. Okay, so sample is placed inside the permeameter. Seepage path is already generated. Seepage path म्हणजे काय? ज्या डायरेक्शन ने वॉटर मॉलिक्युल्स ट्रॅव्हल करतात टॉप पासून बॉटम पर्यंत, त्या पाथला म्हणतो आपण सीपेज पाथ. Okay, seepage path is generated. Now fill the standpipe which is connected at the top of permeameter by using water level. आता ती water level कुठपर्यंत भरायची आहे? That depends upon the researcher. Suppose I am interested to set the initial head, say 90 centimeter. हा head आहे 90 centimeter. The dotted line, this indicates that is a wall background. एक wall mounted board असतो. On that board readings are marked. Okay, which is going to support for the observer to take the proper reading. And the main water level is in the standpipe. So when you are going to fill the standpipe by using water level, you decide what will be the value of initial head. If you set any value, suppose I set 90 centimeter. When water meniscus comes to 90 centimeter exactly here, don't stop the filling of water inside the permeameter, inside the standpipe. Okay, now level is marked. Initial H1 head is there 90 centimeter. Now take the stopwatch in your hand, and once you start the stopwatch, you have to release the water. Outside of the permeameter there is cork is available. Okay, the tab is available which is used to closing and opening of water outlets. Okay, so hold your one hand near the tab, one hand hold the stopwatch. As soon as you start the stopwatch, release the knob so that head from 90 centimeters starts going decreasing in downward direction, because the water starts seeping through a seepage path. We are not going to collect that water sample. We are going to measure only the head. Now we decide what will be the head essential. We are not going to decide the time. आपण काय करणार आहे? We are going to decide the what will be the value of initial head H2. H2 पर्यंत जाण्यासाठी किती टाइम लागणार आहे? That we are going to measure. Suppose my H2 head is say 50 centimeter. Okay. Now one more time, listen. Initial head 90 centimeter. Then start the stopwatch. We open the tab. Open. As soon as tab is open, water starts flowing through a soil mass and level decreases. Once the level reaches to 50 centimeter, stop the stopwatch. Now what you get after this? We have a time required for a head H1 to drop to the level of H2. Now by using time, head H1, head H2, length of sample, area of sample, and one more, area of standpipe, that is small a. So what I said, whereby using initial head H1, final head H2, time required, then area of soil sample, length of soil sample, area of standpipe, we can calculate the permeability by using this formula. Okay, what is the formula? K equals to small a into L upon capital A into T, log to the base E H1 upon H2. Same formula we can arrange in terms of log to the base 10. Here base E, now base 10. When we use base 10, the multiplying factor we use as 2.3. Okay, so in this expression, the terms are same. Only change is the log to the base E, log to the base 10. What is A here? Small a, area of standpipe. How to get this value? Pi by 4 into diameter square. Which diameter is there? Diameter of standpipe, which is always given in the problem. Now, what is L here? Length of soil sample in a direction of flow. In direction of flow. What is A? Area of soil. How to get area of soil? Area of soil is nothing but area of permeameter. That is pi by 4 into diameter square. Which diameter? The diameter of permeameter. Okay. What is E here? Time required for a head to drop from H1 to H2. Okay. And H1 initial head, H2 final head. Okay. Now, this is a very simple as far as GATE exam, MPC exam is concerned. There is no need to involve in detail how this expression comes. Simply remember the expression for finding the permeability in both constant head and variable head method and try to practice more problems on that. But here I would like to explain how this expression comes in reality. Okay, so for that, look at the board. Discharge is equal to, take here, discharge is equal to volume upon time. What is volume? But volume is equal to area into height. Okay, replace. Discharge is equal to area into height by T. Now, this head and T, I am going to write like this, Q equal to dH upon dt into A. And we use minus sign. Now, what is the meaning of this minus sign? Minus sign indicates decrease of head. Head decreases. And dH by dt means change in head position with respect to what? Time. So for this, I will mark expression number 1. We learned in a constant head method, discharge again expressed as A K H by L. A K H by L by using concept of constant head method, that I will mark as expression number 2. If discharge in both expressions are constant or equating equation 1 and 2, I will write A K H by L equals to minus dH by dt into A. Now I am going to transfer the terms. Look at the board. AK by this A comes to the left hand side by AL into dt. This dt transferred to the left hand side. AK AL dt is equal to minus dH into minus dH divided by H. Okay. Now let's take integration on both sides. We take the integration T1 T2 AKAL into dt is equal to, take minus sign outside, integration H1 H2 dH by H. Now this AK upon AL is a constant because these terms are related to the soil, and to remove this minus sign there is a concept in mathematics, change the limits. Okay, so T1 T2 as it is, AK AL dt is equal to, now I am going to change the limit, H1 becomes H2 and H2 becomes H1 dH upon EH. Okay. Now we will take the integration. So AK AL goes outside. AK upon AL integration of T1 T2 dt is equal to 1 upon integration of dH by H becomes what? Log H limits H2 EH1. Okay. Now what is the derivation? What is the integration for dt? Is a T. So AK upon AL into T limit T2 T1 is equal to log of H limit H1 H2. Okay. Now again simplifying this, AK upon AL upper limit T2 minus lower limit T1 is equal to log of H1 minus log of H2. So logarithmic difference, log H1 minus log of H2. Now T2 minus T1. What is T2 here? Final time when we stop the stopwatch. What is T1? Initial time when we begin the stopwatch. So what is the beginning time? 0. So T2 minus 0, it remains T2. That is nothing but what? Total time taken by water to pass through a soil mass when head H1 comes to H2. So it remains only as what? T. So AK upon AL into T is equal to log to the base E H1 upon H2. I want permeability, so I am going to transfer the term to the right hand side. So AK T equal to AL log to the base E H1 upon H2. Okay. Now done here. Now K equals to AL upon AT. This AT transferred to the right hand side, log to the base E H1 upon H2. And this is the expression for finding permeability of a soil mass when head is variable. Okay. So here completes second method for determination of permeability. Now after this, let's move to the third method, which is a field method, that is pumping in and pumping out test. Pumping out test. Most important sentence for 1 mark in all examination. Pumping out test is a field method. The values of permeability are obtained directly on field. There is no need to bring the soil samples to the laboratory. The testing is done on site. So first important point, it gives in situ values of permeability with minimum disturbance. In situ means on site. The values obtained for a permeability by this method are very accurate, because we are going to provide minimum disturbance to the soil. Remember, when we bring the soil samples to the laboratory, we are going to excavate the soil, and that soil is filled in any container. When we fill that container, the soil is going to change its natural condition. Therefore, values of permeability are not according to its natural state. But in this method, we are going to provide minimum disturbance to the soil. Next point, drawdown and discharge is observed in an observation well. Whenever we perform this practical on field, we require 3 bore wells, main bore well and 2 observation wells, and we are going to keep a record of drawdowns and the discharge in main well as well as in observation wells. How these arrangements and what are the observation wells and where they are located we will discuss later on. Next important point is pumping is at uniform rate to obtain steady state condition. This is very important line, you mark by underline, different color pen. What is mean by steady state? Steady state is the condition where there is a possibility of very negligible changes in drawdown. Drawdown is the amount of quantity of water extracted from the main well, then level available in the well remains steady, constant, even though discharge is continuously at the constant rate. So for that, while performing this test, we are going to take the water out of the well till well attains steady state condition. Okay, so steady state means negligible variation in drawdown. Okay, आपण काय करणार आहोत? By using pumping units, we are going to extract the water from wells. The wells constructed below the ground surface. Once we start extraction, water level which is present initially at below the ground surface, that level slowly decreases. One stage reached where extraction by using pump is continued. पंप ने पाणी बाहेर काढणं चालू असतं, पण वॉटर जी लेवल असते वॉटरची ग्राउंड सरफेस मधली त्या वेल मधली ती स्टेडी राहते, कॉन्स्टंट राहते. डिस्चार्ज चालू असतो पण लेवल कशी असते? कॉन्स्टंट. When that stage is reached, that stage we call as steady state. Okay, now a detailed presentation is drawn on board. Let me explain one by one various components of this pumping out test. The middle one, whose diameter is comparatively more, is called as main well. See, this is the ground level. We are going to drill or make a borehole below the ground surface. So this is the main well. Adjacent to the main well, another two wells are constructed, and these two wells we call as observation well. Observation well number 1 and observation well number 2. The center to center distance between main well and observation well number 1, center to center distance between observation well and main well we denote by symbol R1. Similarly, center to center distance between main well and observation well number 2 we denote by symbol R2. The radius of main well is small r. What is this capital R? Capital R is the position or the point where drawdown level is 0. What is drawdown? Drawdown is represented by symbol S. How to identify drawdown? The dotted line by white color chalk is the initial water level in the ground. It's the initial water level. When we start extraction of water by using pump, when water get extracted, then this level slowly decreases. That decrease in water level with respect to initial one, that height is called as drawdown, denoted by symbol S. S is the drawdown in a main well. Similarly, S1 is the drawdown in observation well number 1. S2 is the drawdown in observation well number 2. This is the point where drawdown is 0, where this falling curve and the straight line of initial water level exactly coincide. That point position from the center of main well we denoted by capital R. This term is known as radius of zero drawdown, or the distance of position of zero drawdown from the center of main well. What is capital H? Capital H is the height or initial position of water table from bottom impermeable level. What is small h? Small h is the water level available in a main well after extraction. When water is extracted from main well, the level drops to this position. Then whatever head is available, that height we denote by symbol small h. If small h is available for main well, similarly h1 is for observation well number 1, h2 is for observation well number 2. Okay, now these are the terms which are used to calculate the permeability of a soil sample by extracting the water. Okay, so when pumps when starts, they extract the water. Outlet is continue. इथं हा वॉटरचा आउटलेट बाहेर चालू असतो, त्याच वेळी ही लेवल कमी व्हायला लागते. अशी एक स्टेज येते की जितकं वॉटर बाहेर चाललंय तितकंच वॉटर इथं मेंटेन राहतं, म्हणजे ही लेवल परत खाली ड्रॉप होत नाही. त्या कंडिशनला म्हणायचं स्टेडी स्टेट कंडिशन. आणि ज्यावेळी ही कंडिशन पोहोचते we are going to calculate permeability of soil by using the expression. Look at the board. The expression used for finding permeability of soil. K equals to small q pi capital H square minus small h square into log to the base e capital R upon small r. Formula is little bit confusing and difficult to memorize at the time of examination. So you practice of writing such type of formulas number of times. K equal to small q discharge pi h square minus small h square log e capital R upon small r. Now what is q? Q is discharge. Discharge but कुठून येतो? From main well. ही जी मेन वेल आहे इथून ज्यावेळी पंप वॉटर एक्सट्रॅक्ट करतो तो डिस्चार्ज किती बाहेर येतो? सिंपली डिस्चार्ज इज इक्वल टू वॉल्यूम अपॉन टाइम. You can take the stopwatch, you can take a measuring jar and measure the volume of water extracted in a specific time. Volume upon time, what you get? Discharge. Okay. Now, what is R? I told about the meaning of R. Radius. Radius of zero drawdown. Radius of zero drawdown. इथं पॉइंट आहे जिथं ड्रॉडाउन काहीच होत नाही त्याचं मेन वेलच्या सेंटर पासूनचं डिस्टन्स. व्हॉट इज स्मॉल r इज अ रेडियस ऑफ मेन वेल. या मेन वेलची रेडियस. ओके. व्हॉट इज कॅपिटल H? थिकनेस ऑफ ॲक्विफर. थिकनेस ऑफ ॲक्विफर. आता हे कुठून मेजर करतात? मेजर फ्रॉम impermeable layer to initial water level. इथे डायग्राम मध्ये बघा, it is measured from impermeable level up to initial water level. Okay, now next is small h. It is the depth of water in a main well. Depth of water in main well. Measured above impermeable layer. It is also measured above impermeable layer. I have one question. How to calculate small h? Because small h we are not going to measure directly, but what we are going to measure? We can measure drawdown. आपल्याला drawdown measure करता येतो. Capital H माहिती असतो. So I can write small h equal to capital H minus s. Okay. So this is the expression to find out the permeability of a soil on field by concept of pumping out water बाहेर काढणे. Okay. This concept we are going to repeat again in a subject hydrology. Okay. There is one chapter well hydraulics. Means how to get the water from aquifers. Okay. So again in that subject in a chapter of well hydraulics we are going to learn again same concept of extraction of water from the ground surface. Okay. So remember the formula which is very important, not easy to recall immediately, need more practice. And again whenever they set a problem of 2 marks in a GATE examination they will provide the terms in the form of statements, and from statements you have to generate the symbols, and once you know what is the value given for a proper symbol, then only it is possible for me to calculate the value of permeability. Okay. So here completes pumping out test. Now let's move to pumping in test. Let's begin second field method, that is pumping in test. In the name of the method, it clearly indicates we are going to move or we are going to pass the water inside the soil. In a previous test, pumping out, we extract the water from ground, but in this test we are going to pass water inside the ground. That water by using pumping system with a constant rate of flow. Okay, so pumping in test is conducted by two approaches: open end test and packer test. Now let's discuss first open end test. Open end test. A PVC pipe or a steel casing is driven inside the ground. That casing is open at both top and bottom. Casing is open at both top and bottom. that casing is driven inside the ground and then soil is extracted from the pipe. The soil which comes inside the casing, that soil is extracted by using special dredging tools. Now after dredging the soil, the casing is ready to pass the water at a constant rate. So most important point over here, clear water is passed or added by metering system by gravity flow with constant head. The flow is under gravity with respect to gravity, and the flow should maintain at a constant head. That is very, very important. We have to maintain head constant when water is going to percolate from top to bottom. Now in this case, what are the main points? Water when flows with a constant rate, we are going to measure the permeability by considering the head as a constant. So this sentence you have to mark by different color pen. Clear water is added by metering system by gravity flow with constant head. So open pipe driven and water is passed. Now by using this technique, permeability is calculated by using the formula K equals to discharge divided by 5.5 into RH. Now what is Q here? Q stands for constant rate of flow, that is discharge. You can find out by using volume and time. R is the radius of casing, the casing which is driven inside the ground. That casing radius we denote by a symbol small r, and H is the head difference. Okay, head difference means when flow is occur, there is a development of head loss. That head loss or head difference we denote by symbol H. So this is the most important formula in MPSC exam for 1 mark question to identify expression. And as far as GATE exam is concerned, possibility of 2 marks question directly based on open-end test. In a problem, they always mention whether the solution is based on open-end test or Packer test. Okay, now let's move to Packer test. The concept of Packer test is very similar. We are going to pass water inside the ground at a constant rate and permeability is recorded. The difference is formula for open-end test and the formula for Packer test are different. Now see what is the formula for Packer test. Permeability is equal to discharge divided by 2 pi LH log to the base 10 L upon R, and this is applicable when L more than or equal to log R. Second formula, K equal to Q upon 2 pi LH, this term remains same, sin hyperbolic inverse L upon 2R, and this second expression is applicable when log the L value is less than log R but more than or equal to R. Now meaning of R is same, that is the radius of casing. Length, L stands for length of hole tested. How much is the length of the testing hole? ग्राउंडच्या आतमध्ये किती डेप्थ ला बोरवेल तयार केलेली आहे, that height is nothing but length of hole. Then H again same meaning, head difference or head loss. Then Q constant rate of flow. The terms which we used in a open-end test, same terms are present in a Packer test. The only additional term is the length of well or length of hole tested. Okay, so these expressions are very difficult to recall in the examination. You cannot write the formula as it is in the examination. For that you need to practice more. Okay, more practice is required. And after this I would like to add one more important point. The formula which we use for permeability calculation in a pumping out test, the formula is like this: K equal to discharge upon pi capital H square minus small h square log to the base E capital R upon small. We use all the terms related to the main well. If you want to take concept of observation well, or you want to take the readings related to observation wells, then you can replace these terms for observation wells in the same expression. And how expression becomes K equal to small discharge as it is pi capital H is a larger compared to small h. So I can write H1 square minus, sorry, H2 square minus H1 square log to the base e. In between R1 and R2, which one is more? The या R आणि small r मध्ये मोठं कोण आहे? Capital R. So in R1 and R2, which one is more? R1. R2 upon R1. Okay. Then कसं तयार झालं? Look at the board. This is your observation well. This is the drawdown. Here is the main well, observation well. So here is the S1, here is the S2, then this one is H1, this one is H2. So H2 is more than H1. So H2 minus H1, and the distance of first observation well is R1 and second well is R2. So R2 is more, R1 is small. So R2 upon R1, R2 upon R1. Okay, so this is another technique to write the formula for permeability calculation when data is given in terms of observation well. This expression is in terms of main well. This is in terms of observation well. Okay, so here completes all field methods. You try to practice writing the formulas number of times. Now what type of problems are coming we'll discuss later on, but till today no problem on pumping in test and pumping out test in geotechnical engineering, because this same concept we are going to repeat in subject hydrology. So you can expect similar question in subject hydrology. Okay, so here completes field test. Now let's move to the concept of stratification. Means what happen when flow is going to pass through a different types of soils arranged in a layers.